Okay, so it's Thursday of week one. This is more or less our second lecture. Um, Last time we reviewed the syllabus. We went through that birthday problem, which is a good just kind of get your feet wet, look at some big numbers type thing. The upshot of that birthday problem, and I'm going to see if my pad is working here. For some reason, my little notepad, I think the pen's out of ink. I'm not sure what's going on, but I couldn't use it there. The upshot, and so I'll just go into Word, from that birthday problem is that we are currently consuming the world's primary energy at a rate that is 10 million times greater than the deposition rate. And so in a lot of ways, there's some parallels to be drawn with a normal retirement problem, right? So if you're out there, have a job, paying into a retirement fund, typically, a person's going to do that over 30 or 40 years and then draw from it for a shorter length of time. So there's never, a perfect balance between a deposit and an extraction rate. But when I first looked at this problem, it was pretty compelling. Like how, and I think it really compels us to say that our conventional energy sources might as well just be called unsustainable, rather than trying to call the energy technologies that we're going to cover in this book, all of which are sustainable or to some extent inexhaustible. I've really tried to move away from the word alternative. It was a word that I think came out of the Carter administration, and I think it still gets used a lot of times by the big conventional energy systems, but I like using either renewable or sustainable. But looking at this number, 10 million to 1, what can you call it but unsustainable? So, and then the other thing that comes out, and I think there's a couple figures to this effect. I guess while I've got them up here, I'll show you what we were just looking at in 101. This is just kind of a reminder of what a small fraction of global energy is currently from other sources. So, as it says here, these are new biomass, solar, geothermal. These are the renewables, 4.7%. And if our total global energy budget is going to get larger, in correspondence with the population, this fraction itself can only get larger too. So I think that's kind of the good news, if you will. Okay, a couple other numbers to review. When we did that human power, maybe when we did the human power last year, anyone remember how much energy a human uses per day? We'll do this kind of quickly.
2,000, I think, just to survive.
Yeah, 2,000 calories. This equals, 2 million calories. And if we look up, let's just go and look up the definition of calorie really quick, and then we'll do calories to joule. Tell me, while I'm doing this, tell me where in the back of the book that little conversion is to. A lot of people forget about that, yeah.
31. Yeah. 1 calorie is 4.2 joules, which I think that's a small calorie.
Where are you looking there?
532.
Oh, yeah, nice, yeah. Okay, there's another there's another physical definition of the calorie, and this gets into thermal energy. Let's see. Oh, here we go. The approximate amount of energy needed to raise the temperature of one gram of water, and a gram of water is a cubic centimeter of water, 1 degree Celsius at a pressure of 1 atmosphere. So that's the thermal equivalent. Not very much, tiny bit of water, tiny degrees. So not a whole heck of a lot, but that's what's keeping us running. So also, and so how many joules is that?
8,400,000.
Good memory, good memory. If you're running with 2,000 calories, 8.4 million, so I'll do it that way. 2,000 calories equals 8, we can we'll just put the commas in there, 8,368. Joules equals I'll just say 8.4 megajoules. Now, if we do it this way and just say, okay, so on the higher end, you might have 2,500 calories, we'll convert that. That's about 10 megajoules. And most of this is reviewed from 101. Now, let's go from energy to power. So knowing that this is the amount of energy that a person consumes in a day, what's one human power? So I'm going to pause the recording, give you some time to play around with that. I'll do it here, and then we'll reconvene and check notes. So again, we got to get from energy to power.